Hi, this is Scott. I really appreciate our sponsors because they make the show possible. Today's show is sponsored by Developer Express. Become a UI superhero with DevExpress controls and libraries. Deliver elegant .NET solutions that address customer needs today. By leveraging your existing knowledge, you can build next-generation touch-enabled solutions for tomorrow. You can download your free 30-day trial at dx.hanselminutes.com. That's dx.hanselminutes.com. One more thing. Let me tell you about a new sponsor, Raygun. If you're wanting to detect and diagnose errors and crashes in your software, even find problems that you didn't know existed to improve your software, then Raygun might be perfect for you. You add a few lines of code to your application, and in minutes you'll get real-time error reports with all the information that you need to fix bugs fast. You can even hook it up to your team chat, bug tracking, development workflow tools. Raygun covers all major web and mobile programming languages, including .NET, the full Xamarin Stack, JavaScript, and many more. Go check out Raygun today at raygun.io. I use this myself on my little startup, and I really, really recommend this product. It is a great, great product. Check it out, Raygun at raygun.io.
From HanselMinutes.com, it's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman. This is Lawrence Ryan announcing show number 476. In this episode, Scott talks with Kassandra Perch about getting started making NodeBots and Wearables.
Hi, this is Scott Hanselman. This is another episode of Hansel Minutes. And on the phone, we've got Kassandra Perch, the node botanist, an educator and mad scientist at Bocoup, and an expert on NodeBots. And I'm very, very excited to be talking to you today.
Thanks. I'm glad to hear it.
So people actually, you just had a book come out with a whole group of people called Make JavaScript Robotics. This is a brand new book coming out this week?
Yeah, it just came out last Friday. I'm really excited about it. It's really a compendium of a bunch of different projects from a really great cast of people. And yeah, it's really great.
So is each chapter an individual project?
Yes, each chapter goes into a different platform of NodeBot or a different skill. And so you can build, I think, something like 12 different projects with 8 or 9 different types of NodeBot with it.
Is this something that's like advanced that like maybe only a programmer would look at, or could I get this with my kids and we could, is this accessible?
I think there's a couple projects that would be good for kids, but most of the projects are more aimed at folks who are already programming and already building things.
Okay, so some familiarity with programming and, be able to turn a computer on.
Yeah.
Why is it that you are so excited about JavaScript as it relates to robots? Because people have been programming robots forever, but why does JavaScript and Node make robots so much more accessible?
Oh, that's a great question. A lot of it has to do with the fact that a lot of people see C and C++ as inaccessible, especially nowadays where folks are being educated not in C or in a low-level language, but they're being educated in things like Python or Java, where they have a good grasp of abstract languages as soon as they get out of school, and they feel that those lower-level languages are inaccessible. Mm-hmm. I think JavaScript in particular is a very easy to adapt to language, and so it's great that we can write robotics without having to get into the deep code, without getting into these assembly languages that can seem cryptic to a lot of people.
Mm-hmm. It seems like for me, when I was learning C years ago, it was always the memory management that was like, why am I dealing with that? I thought we were moving a robot from left to right, and now you're telling me I have to malloc?
Oh yeah, definitely. Memory management is a huge issue that is taken care of when you write with a higher level language like JavaScript.
Mm-hmm. And is there an aspect of the eventing concepts around like how Node works, like that an event shows up, an event-driven programming? Does that change things?
Definitely. It moves a lot of, trying to wrap your head around interrupts. It can be tricky, but wrapping your head around an event system, especially if you're already a web developer and you deal with events all day, moving into that with robotics is definitely, Chris Williams does a couple of really great talks and has a couple really great blog posts about why the evented system in JavaScript adapts so well to robotics.
What do I need? Do I need to go and buy like a robot kit, or can I simulate a robot and get started? Like, what's the hello world for a NodeBot?
Yeah, some folks are working on simulations with robotics, but right now the best way to go about it is to get an Arduino Uno or some form of Arduino board. Mm-hmm. Luckily, these can be very cost efficient. You can get a Scene Smart, which is an Arduino compatible board, for about $15 on Amazon, and you can get a pack of components for about $5 that will allow you to do the basics. The Hello World program would be kind of the blinking of the onboard LED. So there's one LED on Arduino Unos that users can control. And so the Johnny 5 Hello World sketch is basically you plug in your board and you run a sketch that blinks that LED to tell you that the board is working and that the computer is communicating with it properly.
Mm-hmm. When I did some basic Arduino myself, that language and that word that you just used, sketch, that's kind of a C-like language. Can you explain the relationship between Arduino, the sketches, and then when does the higher level JavaScript come in?
That's a great question. So, what a sketch is in the terms of the Arduino world is a piece of C, C++, or a lower level, or even processing that you can load directly onto the Arduino board that runs. Where JavaScript comes in is you load it's a very special sketch. It's kind of an OS of sorts called Fermata. And what Fermata does is it allows the board to run through communications on the serial port, which in our case is USB ports from our computer. What Johnny 5 does is it uses Fermata, and you write a Johnny 5. I call them sketches. A lot of people just call them programs. But what it does is it communicates with the Fermata on the board and sends special instructions to basically translate your JavaScript commands into commands that are run on the board.
I see. So it makes the Arduino a terminal of sorts, a receiver. So rather than becoming the brain, it becomes the listener.
Yes. The Arduino essentially becomes a thin client that just waits for instructions from the serial port.
Mm-hmm. Now, is that a good thing? Like, I could see someone saying, well, wait, I thought that the robot was going to be smart, but now the robot is an extension of a computer that I have to have somewhere else.
It definitely can be seen as a limitation that you have to tether your Arduino to a computer that's running Node. But with new platforms that are coming out by the day, there are actually now platforms that run Node on it, much like the BeagleBone Black or the Raspberry Pi that run Linux and Node on the board. You can actually run Johnny 5 with those, and you don't have to tether it. It's just running directly on the BeagleBone or on the Raspberry Pi. And then there are microcontrollers that now run JavaScript natively, such as the Tesla, which has been out for a while, and the sequel, the Tesla 2, is about to come out. I'm really excited about that. And the Esperino, which runs, it's a very modified version of what looked like client-side JavaScript, but it's definitely still an application that you could use if you wanted to break the tether of Fermata. And
the Tesla 2 that you said you're excited about, that comes out later this year, and it's only going to be $35.
Yes, that's definitely one of the biggest things I'm excited about. They've managed to make it more powerful, more useful, and cheaper all at the same time. Oh, and smaller. I'm really excited about that. And they're working really hard to make it a great product. Yeah, it looks like it's got 64 megs of RAM. It's got a nice little processor. It's going to do everything that we need in 2 USB ports. And the part that I think is the most interesting, at least in the context of robots, is it's going to have Wi-Fi on the thing, which is, I think, important. Yeah, the Tesla 1 actually has a Wi-Fi chip as well, as does a few other platforms like Spark. However, the big update is going to be they're moving from a Texas Instruments Wi-Fi chip, which has been riddled with issues, into, I believe Spark's moving to the Broadcom chip, and I'm not sure which one the Tesla's moving to, but both of these chips are much more stable and much more easier to interact with. I believe it's called the CC3000, has just been a huge issue in terms of reliability. And I'm really glad to see that we have options now. Yeah, I'm not as familiar with the details as you are, but I know that I recognize the names like Broadcom. And I know that on my laptops, those have been very reliable. Yeah. Broadcom, the problem was, if I remember correctly, had to do with open sourcing and drivers. And I believe Broadcom's made some really good steps into allowing drivers to be written by other parties. And I believe that was really the breakthrough that allowed that technology to move onto the boards. So as a newbie, when I get into this, how much of these kinds of details do I need to know about? Or how much time can I spend up in the Node high level, I'm moving a robot around, versus the, man, I'm getting flaky Wi-Fi, or I need to go and get new drivers for this or that? Yeah. Luckily, my answer now is much better than it was a few months ago.
Really? Even as recently as a few months ago?
Yes. Even there actually was a firmware update to the chips that I mentioned that were a little bit unreliable that has made them much more reliable. The only problems we really have now are when we do hackathons and we have 30 chips in the same room, there's a little bit of an issue. But just for the average user that buys a board, brings it home and runs it, it's gotten a lot more stable. Luckily, a software update managed to repair a lot of the issues as long as you're just using one board or two.
So I've heard you say Spark, and they have the Core and Photon Electron. I've heard you say Tessel, Raspberry Pi, which I'm familiar with, and also Arduino. That's quite a diverse group of different systems. All of them are running the same libraries and using Node in the same kind of way?
That's the best part. You have options. So one of my favorites is definitely Johnny 5 because you can run the same code on all of the aforementioned platforms and even more. The Johnny5.io website just came out a few weeks ago and it shows all the platforms that it's available for. And you can use Johnny 5 with all these platforms. With the BeagleBone or the Raspberry Pi, you can just run Node natively and there's libraries to control the GPIO pins. The Tessel has its own library set up. But yeah, that's the best part is with Johnny 5, you can get started immediately without knowing a lot of the details of the board that you're using, especially because the documentation is just so fantastic. Especially with the new website, they made it look a lot prettier. So yeah.
Yeah, I'm going to put links to all of this in the show notes, but Johnny 5 is at johnny-5.io. And I think it's so funny that the people, particularly people like my kids that are going to start doing this kind of stuff, will have no idea who Johnny 5 was or why he was one of our great heroes.
I actually hadn't seen the movie until I started working with the library. I then saw the movie.
Didn't that immediately make you want to build a Johnny 5? Like, that's the thing about Johnny 5. It's like, I must have one. He's like R2, we need one in the garage.
Yeah. Some of the work that's been done with hexapods by Rick Waldron and Donovan Buck has been amazing. And I would definitely take a look. Donovan did a talk for, it was either Empire.js or Empire Node on his hexapod, and it walks and dances and responds to commands, and it's amazing what you can do with NodeBots at this point. I specialize in wearables, and I now have 2 outfits that are going to be ready for JSConf that are all powered by JavaScript. And so I'll be all lit up and sensorified and Internet of Thingsed, as my sibling put it. That yeah, it's going to be interesting.
That's fantastic. And hexapods, for people who may not be familiar, they're spider robots, basically, robots that have 6 legs. So you say that you're specializing in wearables, and you mentioned sensors. How many kinds of sensors can one bring in to their NodeBot?
Oh, wow. That's growing by the day. Johnny 5 alone supports, I think, 25 to 35 different types of sensors. And we just cracked I2C support on a bunch of platforms, which opens up a whole new realm.
So what does that mean? What is I2C?
I2C is a different type of protocol. So basically, when you have a standard sensor, you plug it into one analog input, and you basically determine the voltage to be the sensor reading. With I2C, each device has an address, and you can plug multiple devices into the same 3 pins. And so you say, I want to read this from this address in order to differentiate between all of the devices that are on the same pins. So not only can you fit as many sensors as you can power onto just a couple of pins, but you can also, a lot of devices now come in I2C that have so much more capability on one little board. For instance, accelerometers really start to shine in I2C because you've got all these different readings, and instead of using one pin for each reading, you just use I2C. You've just got the same 3 pins, and you get the data in a nice little byte packet.
Okay, so there's my brain is exploding because there's so much good information there. Let me see if I can paraphrase some of that, and you tell me if I got it right. So I know with my Arduino, I can stack the shields, right? I can have my Arduino and I can put stuff on top of them, but I do have to, at least before you just told me this, I have to be aware of what's on what pin. You're telling me that I2C, and people can search for that using the letter I, the number 2, and the letter C, I2C, I2C, that this is a way of kind of multiplexing things across one pin. It lets you not worry so much about that.
In fact, a lot of shields use I2C. So that's how you're able to stack those shields, is each shield has its own address. And so it's using your I2C pins and it has its own address so that you can use as many shields as you can power.
So should I go through my shields that I've got in my closet here and maybe kind of put the ones that support I2C aside and say, all right, those are the best of what I'm going to be doing. And then maybe the other ones are older shields that I might not need.
Maybe. What I would definitely do is check Johnny 5 support. If you're looking for doing with Node, I would definitely check the Johnny 5 website and see what shields are already supported. And then out of that, outside of that, if it's not supported yet, I would definitely take a look at implementing it. I2C, once you get the addresses and figure out what's going on, you can implement I2C in Johnny 5 fairly easily, and you could end up putting a pull request back to the repo.
Oh, there you go. So I'm up here on the Johnny 5 website, which is, and seriously, we've all seen a lot of websites. Everyone looks at a website and they go, oh, this is Bootstrap. This is a gorgeous website.
I actually did a little work on it.
Seriously? Very, yeah. I just clicked on platform support and there's this grid of all the different Arduinos that it supports. And of course, being the jaded old web person that I am, I'm like, oh, here's some clip art. And I click on them and I go to this fantastic page called platform support and it lists out dozens and dozens and dozens of different devices with a clear yes and no about what that device supports. It is just fantastic.
Yeah, a lot of that work was Rick Waldron. So that's one of the things I have to say about my employer is this was a project that my employer actually gave us time to do. They are a huge supporter. Bocoup is a huge supporter of the NodeBots movement. Rick works there, I work there, and Rick and Matt Marquis and I all worked on that website to make it shine and make it look great because previously we were using GitHub wikis and that was getting a little unmaintainable, so we moved to a full website. And our designer did a great job of tying things together, and I really like how the website came out.
Yeah, I mean, it's not just that it's pretty, but the idea that it's got the answers I want. It's like I have a device, it's sitting right next to me. I don't know, it's some kind of older Arduino. I go up here and I think, oh, there it is, Arduino Mega, and suddenly I feel like I can do this now. Like, I may have a NodeBot running by the end of the day.
Yes, that's the best part about Johnny 5. The community cares so much about documentation, and they see, I remember one time we were on IRC and someone said, well, I haven't really contributed to Johnny 5. I just put docs in, and Rick immediately jumped in and said, no, that means you've contributed to Johnny 5, because without our documentation, we would be useless, because everybody would look at the library and say, well, I can't use that. And our documentation is really what makes us shine as a usable library. You can see that in the documentation that, oh, I can do this. This is just a few lines of JavaScript and it supports the boards I already have.
What is this word fritzing that I hear everywhere?
Yes. So all of the diagrams that you see in the documentation that show you how to wire things together are done in fritzing. It's a very great open source project that's kind of CAD software, but it has all of your components and all your boards already done I call it clip art, but it looks so much nicer than clip art kind of style. They take a lot of pride in their graphics. And so it's easy to diagram out what you've made in fritzing, save it as a PNG and upload it to a website. And that's part of what makes our documentation shine is the fact that fritzing works so well is we can just kind of quickly write up what we're doing and throw it up on the website. And it makes the docs so much easier to make that we don't have to draw our own boards out.
I want to take a moment to thank our sponsor, Syncfusion. Syncfusion's mobile, web, and desktop controls are trusted worldwide, but did you know that they also provide educational resources? The Succinctly series of free ebooks has great content on popular technologies in 100 completely ad-free pages. These books are written by industry experts, and topics range from Cassandra to Node.js to Windows 8.1. They are available for Kindle apps and in PDF format, and new ebooks are released each month, so browse their library at syncfusion.com to download your free ebook today. One of the things that I think turns people off when they start getting into electronics are using the standard electronics diagrams, and the triangles and stuff. I mean, I remember doing this in college, but honestly, I'm just going to be Googling for like, what does that look? Is that a resistor? And the fritzing diagrams and the cleanliness of it kind of goes, I'm sure that there are purists in EE that are like, not okay with that. But it's so much more accessible to myself and for my kids to be able to put something together with these.
Yeah, I find the purists to be a bit arbitrary. Like if you're working in EE and you're building a chip, I can definitely understand the use of the classical style. But I think for applications such as hobbyists would do, like with Johnny 5, I think fritzing really makes it a lot more accessible and a lot easier to read.
Yeah, it's so important. I worked with my 13-year-old nephew recently to hook up an LED to a Raspberry Pi. I think we spent probably 4 hours trying to do this just to get the concepts across to him. But when you go to Johnny 5 and you click on LED blink, it's like, oh, there's a picture of an LED shoved right into the Arduino directly. I didn't have to go and get a breadboard. I didn't have to get a resistor. You got me to that LED moment fast.
Yeah, that's definitely something we also take pride in is, I believe I can attribute it to Rick's teaching style, which is, the faster you can show someone something, the more likely it is they'll want to know how the code runs. So when he does a workshop, he says, okay, so basically just follow along and then I'll explain what goes on in a minute. Because if you can get a student to blink an LED, they'll want to know how that code works. And I think that theory really applies. I've started adapting it to my own kind of teaching style. Now when I teach, Node, just plain Node, no robots, I actually will build a robot and give it a REST API. And then I will have students build a web app that interfaces with that robot. And you would be amazed how excited people get when they can make a light on a robot turn green or purple or blue just from their web browser. And they get so much excitement out of building a web app that can do that. And then, of course, there's always some interest at the end of the class of, oh, well, how do I build that robot?
Yeah, I think that's actually why we started this conversation on Twitter, was you were talking to someone about that LED moment. And my partner Saran and I, when we did our Marches for Makers, we just came up with that idea too, because it's one of those ideas that's like, yeah, I remember the first time I was able to like push a button and have a light go on, because it's like, it feels like it went from the world through your brain and then back into the world. And that loop, when you close that loop, it's like suddenly you're powerful.
Yeah, I actually, a lot of people ask me how long I've been doing NodeBots, and they're very surprised to hear I've only been doing robotics at all for about a year. I guess,
Are you
well,
kidding?
2 years now. Yeah, it's only
goodness.
been 2 years. What happened was I was at JSConf 2013, and Raquel and Rick showed me how to build a NodeBot, and I'd always thought that hardware was just beyond me, and it was just something I couldn't do. And I had built an RGB LED that responded to a web page in about 8 hours of work. I didn't leave the NodeBots room for 8 hours. I was so excited to build this. And the fact that I went from no hardware experience to building that, it just inspired me to build. I left knowing I wanted to build a light up dress. And at JSConf 2014, I had that. I had a dress that had LEDs on it, and they reacted to an accelerometer. And I've built that into, I now have a skirt that does that as well. I have a tuxedo jacket that reacts to the weather. I have like 8 or 9 wearables projects just sitting around within 2 feet of me in my lab right now. And all because of that LED moment, all because it was just so easy to get into robotics and see the documentation and think, oh, I can do this.
How much, let's get down to the soldering though. Like that's the thing that slows people down. How much soldering am I have to do? How much, how many multimeters am I going to need to get? When will I hit the multimeter moment where things suddenly slow down?
For me, I got my first multimeter for Christmas 2014. My dad is an electrical engineer, and he said, well, you've been working with robots enough so that you're going to start needing a multimeter soon. And sure enough, he was right. They're really great tools for detecting shorts. And, when you work with wearables, you work with, threaded wire that kind of frays. And so you can get shorts pretty easily, especially with conductive thread as well. So he was right. I was using that multimeter within a couple weeks to detect shorts and find problems. But, on the other hand, if you want to build something stationary, or if you want to build something that doesn't need to be worn, you can actually get away without soldering for quite a while. There are quite a few projects built on breadboards that just kind of either sit on windowsills, or they're just stationary. So you can get away for quite a while without soldering or multimeter use. But Honestly, it's funny how much of a barrier has been put around soldering and around multimeters, when really all you need is the right documentation. When I found a website on how to use my multimeter, it made the manual. I threw the manual out the window and just resulted to the website because it was just so much easier to read. I think there's such a cryptic barrier around all these electronics that if we can just break that down and document what we're doing, we can invite so many people into this hobby that think they can't do it.
I think you're absolutely right. And I've used my multimeter. I've had the same one my dad gave me 20 years ago. But even now, because I really don't fully understand how to use it, I just turn the knob until I see a number that doesn't look insane. And I really need to put a little more thought into that.
I think it's not just people need to put more thought into how they use tools. Like I said, I think it's just as much up to the people who do know how to use those tools to turn around and give back to the community. I always say when I give a talk about robotics, the best thing you can do is document not just your successes, but always document what went wrong and why. And because that documentation is what's going to bring new people into the robotics hobbyist area, is that documentation is going to show them that, oh, we're human. All of us have blown an LED up. All of us have most of us have seen the blue smoke monster, and we're okay. And life goes on, and you can do this, and you can build these things, and you're not going to break anything, and you're not going to hurt yourself.
That is a good reminder that this is low voltage, so hopefully you won't burn your house down.
Yeah, unless you're working with relays, the likelihood of you hurting yourself or anyone else is remarkably small.
Mm-hmm. There's another site that Johnny 5 links to that says Node-ARDX, and that has a lot of really great information. It's a little more kind of low level, a little more detailed, and it has diagrams as well as traditional electronics diagrams. What is that site?
That site is a walkthrough. So the ARDX is a kit that comes with an Arduino and a set of components. And the writer of that site, what she did was she said, okay, I want to walk through the same tutorials that come with that kit, but in Node. And so that's what she did, is she wrote that entire site that walks through the same manual that comes through that manual, or comes with that kit in C, and she goes through it with Node. So definitely a great place to get started if you're interested in learning about NodeBots, is to just get the kit and follow through with Node or ARDX. It's a great website, and she's put a lot of thought into the documentation and a lot of work into it.
Yeah, that's Anna Gerber, and it looks like a really amazing site. And the kit is really extraordinary, too, because to make things accessible, they've printed out the wiring as pictures. So it's like a top-down version of the breadboard. And it's like, yeah, put the wire here, kids. Which for me as an adult makes me very, very happy.
Yeah, I'm a visual person, and so the photos and fritzing diagrams are usually what I go to, because I'm terrible at memorizing symbols and things. So I definitely rely on the pictures of what's going on to see when I'm replicating something.
Okay, so we're blinking lights, we're responding to sensors, but you talked a little bit about relays. Can you talk about relays and motors, and how do I actually make this thing roll across the floor?
Yeah. So relays would have to do with electronics that are outside the realm of Arduino. So if you want to light up a lamp with a text message, you would wire up the lamp to a relay. It allows you to use higher voltage technology with the Arduino. Whereas motors and servos, they tend to use a little bit higher voltage, but you can start with 5-volt motors and servos. What I do if I was interested in movement is definitely, again, back to Johnny 5. Donovan Buck has done some amazing things with what's called the animation library. And it allows you to time robotics movements, which was something that was previously not something we were capable of doing with NodeBots. And that's how the hexapods work. It's amazing how much balance it requires for a hexapod to walk. And so without the animation library, those hexapods wouldn't be able to walk because we wouldn't be able to time the leg movements properly. So if you're interested in movement in robotics, I would definitely take a look at Donovan Buck's work in general, and definitely take a look at the animation library in Johnny 5.
Okay. And I'm seeing, I've got this kit that Radio Shack went out of business, so I ran over there and bought anything that looked interesting. It's ridiculous, but I have like this Arduino motor thing. I've got DC motors, I've got servo motors, and I've got stepper motors. I don't know which one I'm supposed to use.
I believe Donovan mostly uses regular servos for the hexapods. Stepper motors are very accurate, and they're mostly used in 3D printing, as far as I've seen. And regular DC motors are for applications that don't require a lot of accuracy because they mostly just have on and off, and they don't measure like how far something is moved. So you can't tell a regular DC motor move 20 degrees, whereas a stepper motor you can, and a servo or a rotational servo, which goes all the way around as opposed to just 0 to 180 like a regular servo, can do. You can say, I want a certain number of degrees.
Okay, so then that makes me think that I'd use a DC motor to like zoom. That would be my like go forward, and I could use a servo if I were going to hook up like an Xbox controller and steer the thing with accuracy. And then maybe if I had an eyeball on top, I might use a stepper motor if I needed real accuracy to move the eyeball.
That sounds about right.
Ah, okay. See, this makes me happy because I feel like I'm understanding what's going on. The other thing is the sensors. There's proximity sensors. There are sonar and things like that. How often do you put intelligence into these things versus remote control? You know what I mean? Like, are they responding to sensors and thinking about stuff they're on their own, or are these kind of RC cars?
It depends on who's controlling it. I've mostly built things that do not, I don't build movable robots too much, but when I do, they're not usually very smart. Whereas, Rick and Donovan have done a lot of work with, Donovan, especially with the leap motion. He has a thing where he can put his hands above the leap motion, and the hexapod will sit back and take the front legs and mimic his hand movements with the front legs. It's amazing. I was completely, just flabbergasted when I saw it. You can definitely make the robots as smart as smart as you want, which is kind of a terrifying statement when you think about it.
How smart are your wearables? Because I think it's important for people to know that robots don't necessarily have to have motors. Your wearables and your dress is a robot of sorts if it's interacting with the environment. Does it know about what's going on around it?
It does. My vest and my shoes know when someone stars or follows me on Twitter.
No.
Yeah. Yeah. It's very funny when I'm at a conference and I have to tell somebody, hold on, I have to charge my shoes real quick. But yeah, I have Twitter enabled clothes. I have weather enabled clothes. Most of mine get their information from the internet, but I do have some that still rely on sensors. I just got a, pitch, roll, and yaw sensor that I'm putting into a pendant that will change the way my clothing looks based on the rotation of the pendant.
How are you getting through airport security with these?
Not wearing them. I put them in my checked luggage.
That's awesome. I just immediately had an image of you taking off in an airplane, and suddenly you're starting to change color as the airplane starts to take off at an angle.
Yeah, I try not to wear them on the plane because I get the feeling I would cause a bit of a ruckus.
That would be problematic.
Yeah.
Oh, right. Oh, my goodness. Okay. So we've got Johnny5.io. We've got the Johnny 5 library, which is kind of like the hub of it all, right? This is where we start with Johnny 5. Is there anything else, or is Johnny 5 the brain? There's no other brain we would want to think about.
There are other libraries out there. Johnny 5 is definitely the farthest along and has the best community, but there's some community around the Tessel, which has its own library, and the Esperino, which has its own way of doing things. But I would definitely start with Johnny 5 because it tends to lead to those libraries and those platforms. So I would definitely start there.
Can I use Johnny 5 with a Tessel?
Not yet.
Okay, I like that. Okay. Not yet. And then I noticed that when I went over to, I found my way from Johnny 5 over to IO plugins. This is where things start getting interesting.
Yes.
Anytime someone finds an object that they want to talk to, they just build a plugin for this thing.
Yes, exactly. And that's how Johnny 5 is one of those write once, work anywhere sort of libraries, is basically you install the IO plugin for the platform you want to use and maybe change some pin numbers. And all of a sudden your code that you wrote for an Arduino Uno can run on a BeagleBone Black or a Lenino 1 or all sorts of different platforms.
On that right there, you threw that out like it was a small thing and changed some pin numbers.
It really is small. So basically, when you write an output, it's to a pin number. And on Arduino Uno, it's usually a digit. However, in some other platforms, it's like a BeagleBone Black, for instance. The pin number would be P, which is the column, and then a number, which is 8 or 9, underscore, and then the number on that column. So, I mean, you have to look up the pin differences, but everything else, the APIs, the event system, it does transfer from platform to platform. So it's truly a minimal thing.
Mm-hmm. Now, you've said Arduino Uno many times, and that happens to be the first one at the top of platform support. Mm-hmm. I think I've got an old one with an Italian name from a couple years ago. Is the Uno the one that people really should start with? Is that you've mentioned it so many times, it's the first one on the list. Is that preferred?
It's the easiest one to get. I think the Johnny 5 community is so welcoming, and the code works well enough on each platform that there is no real one you should start here platform. Mm-hmm. It's just the Uno is so easy to get and so cheap. Really?
Yeah, it's like $20.
Mm-hmm. That's usually why it's at the forefront of the Johnny 5. And also it was the first board that it was tested with. So I think it's got a special place in our hearts as the first NodeBot.
Mm-hmm. And that one does not have Wi-Fi, correct?
No, it does not. You can get shields for it, but I don't think Johnny 5 has compatibility for those shields. If you're looking for a Wi-Fi out of the box, I would look at Spark or Tessel, but Tessel doesn't work with Johnny 5 yet. So I would look at Spark or Electric Imp, which is a really nice little SD card shaped microcontroller. Mm-hmm.
And are you usually just using a really long USB cable for these kinds of things?
I usually use Wi-Fi enabled NodeBots, so I don't. But Rick,
what do I put on top of an Arduino Uno then to get that Wi-Fi? A Wi-Fi shield?
Yes. Or you could use Bluetooth. If you have a Bluetooth breakout board, you can connect to your laptop with a Bluetooth serial connection.
Okay.
But yeah, if you're interested in doing basically what's called a wireless NodeBot, I would start with the Electric Imp. But yeah, okay. Donovan and Rick can tell you where to get really, really long cables for the Uno because their hexapods have really, really long tethers on them.
Ah, okay. Mm-hmm. Well, maybe you'll make an introduction and we'll do part 2.
Yeah.
Well, this has been so much fun. Thank you so much.
Thank you.
This has been Kassandra Perch talking to me about NodeBots, and I'm ready to start building something. This has been another episode of Hansel Minutes, and we'll see you again next week.